Hello and welcome to Learn Data. It's great to have you on this channel. I'm Nilesh, and in this video we'll continue to learn about time in Pandas. Specifically, we'll look at slice versus exact match when we are dealing with time series as index in a series or a data frame, and then we'll look at the index resolution of a time series. Is it seconds, minutes, and then we'll look at another example of exact indexing and how that can be used. Finally, we'll conclude the video with truncate and how it differs from slicing. So let's get into Jupyter Notebook and start coding. Here I've already created a new notebook and imported three libraries: NumPy, Pandas, and datetime. The first item that we are going to look at is slicing versus exact match. So let's write that: slice versus exact match. And for this, we'll go ahead and create a series, pd.series, and this would be 1, 2, 3. And for this, we'll also add an index using the date range. So pd dot will directly use the DatetimeIndex, and here I'm going to specify the strings 2020-07-31, and let's say 2300 hours 52 minutes and 0 seconds. So that's the first one. Then we'll go on and make the second one: 2020-08-01 and 000000 hours. And then the next one, 2020-08-01, and here we'll add some minutes to this. So 000200. So that is the index that we have created. Okay, so finally we have a series that looks like this. Now if we were to look at the resolution of the index, so what we can type is a.index.resolution, and this tells us that we have minute resolution, because in each of these in three indices, the second part is all 0, so the only minute is the one that has some values in it, 52 or 2. So we have a minute resolution there. Now if we are going to subset this using, let's say, hours up to resolution up to hours, how do we do that? We also did some of this in previous video, so this could be repetition part of it. A in square brackets open quotes, we are going to specify the string 2020-07-31 space 23. So as you can see, because this was a partial index for the timestamp, we got the value along with the index as well. Had we specified 5200, then we would have gotten just the value as is. Let's look at now if we can change this. So if we put 52, we still get a value, and that's because the seconds part is 0, and 52 is the minute resolution, so we are specifying the entire resolution available, and there's no more data after this, so we get a value back, scalar value back. And this is the same as what we looked at earlier, which is specifying 00, get the value. And just for sake of it, let me go ahead and add this and add. So now we can see, as we increase the resolution going from hours to minutes to seconds, we can see that as soon as we reach the value where we reach the limit of resolution, we get the scalar values out, and we do not get the index in the output. Now how does this work with a data frame? So with a data frame, and for this what I'm going to do is create a data frame df. So df is equal to pd.DataFrame, and here I'm going to create a column x, and that column as well is 1, 2 and 3, and then also add another column y that has column value say 11, 12 and let's say 13. And for the index of this one, let's see, index, I'm going to add the index which we have created up above, which is the index from a. So let's just put a dot index here. And if we look at the data frame, this is the data frame that we have. Now here, if we want to pull the data again using partial index with just the year and month, the way we would do that is by specifying df.log, and then within square brackets and quotes we want to specify the string 2020-07 for the rows, and then for columns we need all the columns. So that's how we can pull just that specific data set which has the month of July and the year as 2020. Here if you look at the index, so df.index, we see that this particular index is exactly the same as what we have here, and we would expect that, but the frequency is set to none because we did not specify any frequencies while we created this index for the series A. Now let's go ahead and change this index. So df.index is equal to pd.DatetimeIndex, and here I'm going to specify just the year and month 2020-07, and then 2020-08, and then we have 2020-09. So now if we look at the data frame, this is, we have changed the indices for this, and the reason to do this exercise was to show you that we have changed the resolution. Now if you look at df.index.resolution, it's now a resolution of day rather than minutes. Earlier what we had here was a resolution of minute, as we can see, and now we have changed that to a resolution of day. So that's one way in which we can change how the index for the time series is set for either series or data frame. Now moving on, let's look at another example. I'm going to go ahead and copy the part where we created the date time, or maybe we can just create a new one. Let's create another one. So exact time, and by exact time what I mean here is that we are going to create a new set of index, and for this index we will go ahead and add nanoseconds as well. So, and then we'll see how we can access that. So 2020-07-01, and let's say 2300, then we have 01.234. let's say that's that those are the seconds we have, seconds, microseconds. And here's the second one, 2020-08-01, and for this we, let's say 2030-01 and 0.98, and then after that we have the last one, 2020-09-01, and let's say 13, 10, and then again 01.771. So that's the index we have created. Let's see what we are missing here. We have the, let's look at the module. Pandas does not have date, oh sorry, it should be date time index. So that's the data frame we have created now, and this has seconds, and we have in decimals also. So we have more resolution than that we had before. So if you look at df.resolution index.resolution, we see that we have millisecond level resolution. And if we were to access this information by using df.log and usual strings, we might run into an error. So let's try that. If I use this and then put that there, and if we use this and the second one, so copy and add that. So here we are running into an error because the error handling during handling of the above exception, another exception occurred, key error. I think the reason is because we have this decimal part. If you remove the decimal part, then we do get the output. However, if we need to get an exact match on nanosecond level, how do we do that? So for that we'll use datetime.datetime. So df.log, and within square brackets we want to specify datetime.datetime, and here we'll specify everything. So 2020 is the year, 07 is the month, 01 is the just 7, and then 1 is the month, and then we have hours, and then minutes, seconds, and then we have these milliseconds right there. Now from here the second date would be datetime.datetime, and for the second one we specify the year. Let's use August 8, and we have the 1, then 14 hours, 30 minutes, 1 second, and then we have these milliseconds. So when we get the match based on millisecond level in this way, then we get the output without any errors, as we see. So that's another way in which we can get a match on the time series data right up to millisecond. You can also go up to nanosecond level. Moving on, let's look at another functionality called truncate. And truncate, when we are using with time series, what it does is, let's say if we are just giving year and month, it will assume the day as 0. So that's the difference between a truncate and a regular slice. Let's create a data frame df, and here we'll create a column A where we have np.random integer, and then we have go from 0 to 10, and we create 10 data points. And for index, let's create index is equal to pd.date_range, and then we go from start is equal to pd.timestamp, and we'll have 2020 string of 2020-07-01, and periods is equal to 10 because we have 10 data points above, and frequency, let's set this to 15 days. Now when we look at the df, this is our data frame. We have a couple of months varying dates as well, and here if we look at the df.index, we can see that we have frequency listed in here. Now if we want to truncate this one, so the way we would do that is df.truncate, and for this we won't use the day, we'll just use year and month. So before and after, so we have to before is equal to something, and then we have to specify after is equal to a date. So for before we'll specify 2020-08. So everything before 2020-08 is eliminated from the output, and everything on and after 2020 let's say 09 and onwards is excluded. So this data would not be there in the output, and then this data would not be there in the output. Now when we run this, we see that in the output we get just these two indices, sorry, not the 9, but we just get these two indices in the output. And the reason is because here, although we did not specify the date for 9, it assumed that this would be in the before the beginning of that month, and therefore it stopped at end of August itself. However, if we were to use a regular method, which is df.lock, and here had we specified 2020-08 and another string of 2020-09, then we would have gotten, sorry, we need the code there, that's my mistake. Now, so we would have gotten these rows right up to the end of 2020-09. So that's the difference between using a truncate and .lock, where the .lock gives everything between those two ranges, including those two endpoints. However, truncate assumes a 0 and excludes everything that's specified in the after field. Now if we look at the if we pull just one column, so df of a, and look at the index of that, here we can see that in the frequency we do see the days specified. Now let's look at a series. We looked at DataFrame. If we create a series from df of a and look at the series, so this is the series we have. And if we apply the .truncate to the series, it would be the same way. So if we say before is equal to 2020-08 and then after is equal to 2020-09, then the output that we get is the same as before, where we got 3.6, and here also we get 3.6. And again, if you use the a.lock, the method using the same method 2020-08 colon, and again we go 2020-09, then the output, there's no second column, so the output would be 3636, should be the same as before. Yes, it is. So here let's say if we were to pick alternate rows, let's say if we want to pick rows at index or values at index 2 and 3, and if we, so this is the output we would get. But if you look at the index of this, what happens is we do not get the frequency part in the output, so that is missing in the output. That, however, when we are looking at indexing from the data frame, even if we got the slice from that, we did have the index part in the frequency part in the datetime index. However, when we, for a series, when we are getting the datetime index by this method, we lose the frequency part. That was it for this video. I hope in this video you learned how to slice data frame, how to get the exact match for the time series, either year, month, all the way up to seconds and milliseconds, and then how to use the truncate function in to extract data from a data frame or series that has index as time series. In next video, we'll continue to learn more about time in Pandas. Please like, share, and click the bell icon below to subscribe. I hope to see you all in the next video. Thank you.